So welcome back. The next thing that we have to do in our bowling scores application is to get the user data off the screen and into the app. That's the dog growling. Okay, so in this segment we will make the connections to the widgets that we need. And we already did set up a listener to a button in an earlier application, so that will be familiar to you. And we will also talk to those text view widgets. We're going to create a custom business class. This is nothing but a Java class that holds our data. And I call it a custom business class because this is how people think of classes that are made to store data that is used in their application. So the business of the application is the bowling scores. And we'll make a class for throwing around bowling scores. So we're going to not only retrieve, but we're going to verify and validate the data that's entered by the user. If they enter 650, that's not a valid bowling score. And we will check then for that invalid data. And this one is kind of key. We're going to organize the data within the application. And you haven't seen how to do this yet. So far we've worked only within activities that don't communicate with each other, except for one activity going to the other and going back. But the life cycle of the Android application is going to start to be interesting. And how do we put data in there that we can share with all of the activities? So we're going to do that in this segment as well. So here's where we left off. We had this design in 2 segments ago, and when we built it, it came out looking something like this. And well, it's okay. It's not great. There's some things that I don't like about it, but that's okay. So let's talk about that. Things that are suboptimal. That's my technical term for crappy things. So we're going to keep a list of them and not go in and change them all as we come to them. We're going to just keep a list of things that we want to add to the application. And those are usually called feature requests. So when you think of something, we want to write it down and keep a record of it, and then we can go through them one by one and start adding them to the application. So the date should be editable. So what we're going to do is we're going to put in here today's date, and that's really easy. From the Java program we can just connect to this widget and we can set the text of that widget to today's date. So when this application runs, you're never going to actually see date of games. You're going to see today's date and then enter the 3 numbers and hit save. But suppose I wanted to enter last week's games. Currently there isn't any way of changing that guy, but there should be. So that's on the list. I want to see the series average. So if my average is 175, did I bowl above my average for this series or not? And that's an easy calculation, and it should be shown here. The edit boxes shouldn't get larger than the space for 3 digits. So if I didn't notice this when I was doing it, but if you kept typing digits in here, this box spreads across the screen, and that's kind of ugly. We can fix that. We can force them not to get too big. And clicking in here and then having to delete the 300 and type in the actual score, that's ugly. So maybe if we click in here, if we press this with our finger and then enter the digits, it should select the 300 so that we type over it effectively, or the 300 shouldn't be there at all. I don't know which, but having to delete that to put in my score is painful. Okay, so the save and history buttons, they probably should be the same size, and they probably shouldn't be together. They don't do the same thing. This save button is corresponding to this part of the interface, and the show history is quite a different activity. I don't want to use the word activity. It's quite a different thing to do. In the application, it's to launch the other activities so that we can see historically how our bowling scores have been. So putting the two buttons right here together, yeah, that didn't turn out the way I like it now. So those are things that are suboptimal, and I'm keeping that list of them, but we're going to move forward. So this should look familiar to you from the last one, and we designed the view, and then we implemented the view. And now what do we have to do? We're going to do this one, create the class that holds the set of scores, and we're going to manage the data in the application, so get the data from the interface and verify it. And what we're not going to do in this segment, we're not going to persist the data in the database, and we're not going to design the database. So I'm saving those for a future segment. And this whole part of the application, the other activity that displays the history of the bowling scores, we're leaving that for future segments, maybe an exercise for the reader. I think we're going to do it. I would like this to actually be finished and posted in the Android market for people to download and rave about. So let's go into the application again and start making these improvements one by one, connecting our widgets and storing the data from the interface. And it's pretty easy, and this is a lesson where you feel like, oh gosh, we achieved a lot in a very short time. So let's go in there and do it. Okay, so this is where we left off. We have an application that has a place to enter 3 numbers, and we have some text here, which we haven't done anything with, and we have a couple of buttons, and this text, which we won't talk to at all. So where we were working, I'm just going to minimize that, not close it. So we were working in the in the layouts. Here we are, enter scores, and remember we worked in this graphical layout editor and dropping in widgets using the layout managers, linear layout and relative layout, and it generated this XML file. Okay, so it's a fairly ugly XML file. It has really, really long lines. So what happens in the code when we run this application? So here's our activity, the enter scores activity, very, very short, and when we set the content view to that particular layout, there's a process that happens called inflating the layout. So it takes the XML file and it builds Java objects that correspond to those things that we had created. So when we have in here, for example, here's a text view, and here are all the properties of that text view. For example, enter bowling scores, and probably the gravity, we're going to center horizontal, and all of these properties of that text view. When the layout is inflated, a Java object of type text view, that's the name of a class as well, is created. And this inflation is very, very expensive computationally. So when we go to talk about efficiency in our applications, one of the things that you don't want to do is to inflate your layouts very many times, preferably once. So if you have a whole lot of activities and you're switching from activity to activity, that's something that you have to consider. So we've got all of these objects that get created for us, and we need to have a way of talking to them in the code. So remember this guy, r.java. This gets generated automatically from from all of the resources. So if you look in here, what we have is a number that corresponds to the things that we created. So the date text view has this number, and that's its ID. So we're going to retrieve a reference to the objects that were created. Like there's the save button, and there's the series total text view. We're going to retrieve a reference to those objects that are created in our enter scores activity. So the first thing that I want to do is we'll do just one first. Let's do a button. So inside of this enter scores activity, we're going to make an instance variable, for goodness sake, a button reference, and it's for the save button. So you remember that thing is down at the bottom of the screen. And this doesn't compile. So hover over it and say import. So from the Android widget package we have the button, and now we know about the button class. So inside the onCreate, that means when this activity is created, we're going to inflate the user interface, and then I'm going to make a little method called set up the views. And of course I hit caps lock. So that's a helper method, and we're going to just put this just make it into a separate little method to keep it out of the way. So a private void is set up one word, and inside of setup views we're going to say that that save button reference variable that we created is going to be, we're going to retrieve it by calling a method find view by ID, and then we'll pass in r.id. There it is. We have one called the save button. So what this method does is it runs out and it retrieves a reference to the object that they created for us when they inflated the view. Now it doesn't compile because, well, let's hover over it and see what it says. Type mismatch, cannot convert a view to a button. So all of these widgets inherit from the class view. So a button is a view, and this method returns an object of type view, but we need to downcast it to an object of type button. Okay, so I don't need these windows right now. That gives me a little more breathing room here. Okay, so all of the widgets that we're going to talk to in this activity, we're going to declare a variable, a reference variable for them, and then we're going to go and retrieve a reference to the Java object that was created. And I hope I named these all well. Now, we have the three edit text objects where we put the game scores. So game 1 score, edit text. We need 3 of those for game 1, game 2, and game 3. And it doesn't know about edit text, so let's import it. Now it does. So now we have a reference to the edit text objects. So let's go down into the setup view method, and we will say that's going to be downcast to an edit text object find view by ID. Did you see how I did that? While I was typing, I hit Control space and it filled in the rest for me. R dot ID dot game 1 edit text. That should work. Let's do that twice more. For game 2 and game 3. Oops, gotta spell that right. What else do we need to talk to in the user interface? Well, we have a history button. Put the buttons together. And we have a text view. Have you figured out the difference between an edit text and a text view? The text view appears as small on the screen. It's not something that you can use your finger to select it. It is editable from the code, but it's not like the edit text fields where you can use your very fat finger and select it or give it the focus in the user interface. So we've got a couple of these. We've got one for the date, and we've got one for the series total. I think that's all. Now it doesn't know about text views, so we're importing these one at a time. Some people would use the wildcard character to import them, and I'm just letting Eclipse do that as it wants to. Now we've got a naming error. It doesn't know about game 3 edit text. So I suspect what I've done is I was sloppy in the, maybe you guys saw this, I was sloppy when I was doing the enter scores XML. So let's go over here and say, and darn it, I need my other 2 windows back so I can see what I'm doing. Show view outline, and maybe that's enough. That one was called game 2 edit text, and that one was not given a new name. So let's call that one game 3 edit text. How do I change the name there? I need the properties window. So show view other, and here's the properties window under General. Okay, so the properties of this one, I did not go and change the name. Game 3 text view. Is that right? Darn it. Gosh, I have no memory at all. Game 3 edit text. Now let's go back to enter scores and do a save, and it still doesn't work. What happened? It cannot be resolved. Did R get updated? Do we have a game 3 edit text? We do not. Okay, here's what I'm going to do. I'm going to clean the project. And it's telling me that I have R opened, so I'm just going to close it. And let's make sure that everything is saved. I wonder if that was the problem. It was the problem. So I changed the XML file without saving it and expected R to know about something that hadn't been saved. And now this one will compile again. Okay, tripping over little things like that sometimes is useful. So we've got a few more. Let's do them. Let's go and get the two text views. One is date. And the other one is the series total. It will look very much like that. I didn't do the history button. It will look a lot like that. Okay. So I have 7 widgets that I now know about. So what can I do with those? I can start to work in here, and I can do something like, well, the first thing I would like to do is, instead of the date text, it just says date of games. I would like to put in today's date there instead of ever showing that date of games. So I'll show you one way of doing that. So just a little comment of what I'm doing. I'm going to put the date for today. So if you want a date object that has today's date in it, you can just say new date. And it doesn't know about that class, so I'm going to go and get it from Java util, not Java SQL. No, there were 2 options on that one. 2 classes named exactly the same thing, but there's no naming conflict because they're in different packages. So we need a date format object. I always call mine df, breaking all the rules for naming, but the date format object is a very temporary one. We're not going to pass him around. We're going to make one, use it, and then we're done. So you don't call the constructor for date format. You call a getter, and it creates an object of that class for you. So we're going to call get date format, get date instance, and the one that has only one parameter, and we will say the style is date format medium. So if you want to look those up and see how you handle dates in Java, you can. The date format class is used to create the string that represents the date. More properly, what we should be doing is specifying the locale. So if we wanted the date presented in French or in Canadian style, which would have the month and the day backwards from the American style, we could specify the locale here, and that would make our application more international. But I'm taking a shortcut here so that we don't dwell too long on this. So I'm going to create a string variable. I'm going to call it CS, which stands for character sequence, and then gets the date format, and I'm going to format the date object today. That looks a bit awkward, and well, it is a bit awkward, but the advantage that you get that you don't really see, that we're not using, is all the things you can do with a date object, and especially the internationalization of it. Okay, so now what I'm ready to do is to tell my this guy to change its text. So if I say date dot, these are all of the things that you can do with that object that was created. The text view object. So there's a lot of them, and it takes a long time to get really good at this, but what I know for sure we can do is call set text and pass in that character sequence that we created just here. So 3 lines of code to get today's date in a good format, and 1 line of code to put that on the user interface. So I left the emulator running down here, and what I'm going to do is just run the application, and it should, without having to stop the video and start the video again, edit out the waiting part. The waiting part we should get very quickly. Our application is running, and today is May the 18th, 2011. So we're making progress. What else do we need to do? Well, we need to extract these 3 numbers from the interface. So remember that the user, when they select this and they enter their bowling scores, 125, 222, that's a better game, and 149. When they've entered those, we need to extract those numbers out of the interface, change the series total to the total of those 3 numbers, and save the data. So what we're going to do eventually is we're going to listen for the save button. So far, the save button doesn't do anything. But we have a mechanism now for talking to all these widgets, and the next part we can kind of turn our focus towards the business part of the application. Let's get this data into an object of an appropriate type. So we've been working in the activity code, the underscores activity code, and we made the connection to the widgets on the screen, and we already learned how to talk to one of those widgets, the date, which is a text view. And what we want to do is to get those 3 scores and put them in an object that represents the bowling scores. Well, we don't have a class for holding the bowling scores, so we're going to make a new class. And this application is not going to be really big, so I'm just going to put everything in the same package. So in the same package where we have our enter scores activity class, I'm going to say new class, and I'm going to call this class bowling scores. So what does a bowling score? Well, I called it something wrong. Look at that, I spelled it wrong. What a good opportunity to talk about refactoring. I'm going to close that, and I'm going to right click on it, and I'm going to say refactor, rename, fix the spelling, and if I had used this identifier throughout the code, it would go now around the code and fix all of them. But since we had just started, it only needed to fix a very small one. So we're making a normal Java class now. So the instance variables are going to be private. And what does a bowling scores have? Usually the name of a class should not have an S at the end. You are defining one thing. So I'm reluctant to put bowling scores here, but if you know that one bowling game, one bowling series has 3 games in it, and we want those 3 scores, that's why there's an S there. So game 1, game 2, and game 3. Each of those should have their own line. That's a convention. And what else do we need to know? We need to know the date. Those scores are associated with a date. And now we don't know where date comes from, so hover over it and use the one from Java util. So it automatically imports Java util date for us. Okay, so I'm going to ask Eclipse to help me with building the rest of this class, or some parts of it anyway. I'm going to say source, generate getters and setters for all of the instance variables. So we got quite a bit of code there for free. And I'm going to ask it to generate for me a constructor using the fields. And all of the fields will be used. So there's a constructor. Notice that it automatically calls the parent constructor as the first line. Well, if that weren't there, Java would put it there for us anyway, creating an instance of object, which is the parent class, if you don't specify a parent class. I don't like to leave that in. I feel like it's a useless line of code. Okay, we're almost done. Gosh, that was fast. We need a toString method. I'll create it up here and then I'll move it down to the bottom where it should be. So public string, toString, and we're overriding the toString method from the object class, so always there is a toString method, but the one you inherit is of no value. I don't know why I can't spell today. Okay, so that's my convention. Make a result variable and then return the result as the last line of code and then fill in the middle. So we're going to put the date and then the 3 scores concatenated together in the string, and we need a date format object, which is a disposable object, meaning that we're only going to use it for a short time. I like medium format because it actually spells out the month instead of the short format. Okay, we have to go and get date format from java.text, and we have to import it. And now, oh, this is not spelled correctly. I should have used IntelliSense to help me. Medium is a final, and the convention is all caps. So let's construct the string. Result gets the date format object. Let's format the date, and we called it date. That's good. And then put in a space and then concatenate game1 and put in a space and concatenate game2. When you break a line in Java, you should take the operator to the beginning of the next line. A space, game3, and that's really all there is. Let's fix up our formatting. Oh, and it didn't like that I broke the line because it expects it's set up so that it knows how much how many characters you can have on one line. You can change that, but it assumes that I have more room than I really have. That's okay. So what have we achieved so far? We have a class now that can hold the information about one set of games, and we have a toString method, which I'm going to move down to the bottom where people expect it to be. We have a constructor. If you have 3 game scores and a date, you can make one of these things. I didn't put a default constructor, and I did that on purpose. I might come back and add one, but that's part of the game. So what else do we need to know about a set of bowling scores? I need to know the total of the 3 games, which is the series score, and I'd like to have the average of the games. So remember when we were looking at the interface, I said, well, it would really be nice if the average of the 3 games was up there. So I'm going to add 2 more methods. Let's see. The sum, or the series, what will we call that one? Calculate series score, which really means add up game 1, game 2, and game 3, and it's going to be an int. The sum of ints is an int. And we can just return game 1 plus game 2 plus game 3, and we're done. And then I want the average. I'll probably use this method later. So the average of 3 ints could be a double. Calculate series average, and it will be the series score divided by 3, and I want to do that arithmetic in double. Okay, so if this returns an int and 3 is an int, then the result would be an int and promoted to a double on the way out. But I don't want the division done in int. I'm going to upcast the result of that to a double and then do the division in double. I think we're done, at least for now. We have a class whose purpose is to hold on to one set of bowling scores, and we can throw that around. So we have a unit of computation, which is going to be the object, an instance of this class. Notice that I didn't store as instance variables the sum of the 3 games or the average of the 3 games. Some people do that, but if the value can be calculated, in general, it's better to just calculate it when someone needs it. If we had stored the sum of the 3 games, and then someone changed the score of game 1, the sum would be wrong. So storing those things means that you have to go and every time someone changes the data that it's based on, you have to go and make sure that you recalculate the calculated values, and that's error prone. People just forget to do it, so you wind up with stale information in your objects. So keep the objects small, and then when someone wants more information about those, something that's calculated based on those, calculate it every time they ask for it, and you'll be sure that the information that they get will be fresh and based on the current values of those instance variables. So this is part of the business of the application. And when we make a new class for storing data about the application, the business part of the application, and people usually call these custom business classes. Let's go back now to the activity and see what the next thing is that we have to do to make this application work. Well, we don't have anything in the activity that will allow us to hear the save button. So what we have working in the application now is that the date appears on the activity, and we can start talking to the widgets because we've collected a reference to each of the widgets that we need to talk to, but we haven't made a listener for the save button, and that's the next thing that we need to do. So let's go back to the interface and let's look at the XML. This is so messy. Machine-generated code is just always messy, and there's spaces where there doesn't need to be space, and there's huge long lines of code that the machine can see all of that perfectly fine. So I'll show you a trick when you're working in this XML editor. If you do a Control-Shift-F, so Control-Shift, hold both of those and then hit the F key, it will format the XML, and it's a little bit easier to look at. Even though it was machine generated, they could have formatted it when they generated it, you're all saying, but that's okay. So I need to find the Save button. Here it is here. So we've got those two buttons down at the bottom, the Save button and the Show History button. And I'm going to put a carriage return in here. And we're going to add a new characteristic for the Save button. And it's this Android on... Let me see what IntelliSense said about that. Okay, IntelliSense is not helping me because I have that close angle bracket here. Just to make this work the way that it worked for you, the way it should, let's go just into the middle of it and add a that's better. We have all of the possible options here, and I want on click. So that's to specify what the event handler will be in the activity for this particular button. And I'm going to call it Save Click Handler. And do a Control S to save that, make sure everybody is happy all the time. So we have no red squigglies anywhere. So we have the name of the method that will be executed when the Save button is clicked. So let's go back to the activity, and we're going to make that method. So a click handler is public and void, and we called it Save Click Handler, and it takes a view. And this activity doesn't know about view, so let's go and import it, Android view. And now, what do we want to do when the user clicks on the Save button? I'm going to put a comment up here. No, not a java.comment, I changed my mind. I'm going to just put a block comment. So this is just for the programmer to see, for us to see. So what do we want to do? We want to get the 3 scores from the interface. I want to validate the scores. I want to create an object to hold the scores. So this is kind of getting the information from the GUI layer into the business layer. So we're making an instance of the bowling scores class that we had just created, and then we can do whatever we want with that object. We can throw it around, we can throw it at a database eventually, and it separates now the work of the user interface from the work of the rest of the application. So when the user types something into an edit text object, which is what our game scores are stored in, it's a string. So let's declare a local variable to get the raw score, which is a string, out of that box, and I will say raw score gets, now we want to talk to the widget. What are the widgets? Here's game 1 score edit text, and we want to say get text which will get the text that's currently in that box. And let's see what that does. It does not compile, and the error message is cannot convert from an editable to a string. I don't know exactly what an editable is, but I'm going to convert it to a string and hope that that's what we want. You know that you can call toString on everything. So I had something here of data type editable. I don't know exactly what that is, but I know it has a toString method, and if they're doing stuff that makes sense, that would convert whatever this gave us into a string that represents what's in that edit text box. So now I have a string, and I'm going to convert it into an int. There is an easy way of doing that. In the integer class, there is a method called Parse Int, and you pass in a string. We don't really have to check if that will actually succeed, because on the edit text box, if you remember when we were creating it, we specified that we wanted it to be a number. So I think that's fairly safe programming. I don't think people will be able to crash it by putting in letters and then have us try and parse letters into an int. Not really sure. So we wanted, but I'm going to go with it anyway. We want to do that 3 times for the 3 text boxes. I should say the 3 edit text objects. So the second one is score 2, and the third one is score 3. And this one was called game 2, and this one was called game 3. So now we have the 3 ints out of the edit text objects, and I want to make sure that those 3 numbers are valid. So a valid bowling score is from 0 to 300. You cannot bowl more than 300 in a bowling game. So I'm going to make a small helper method that returns a boolean and is called isValid, and it takes an int which is a bowling score, and we will just whip this up quick. If score is greater than 0 and score is less than or equal to 300, and I guess 0 is a valid bowling score. I don't know if anyone has ever scored 0 in a bowling game. Return true and return false. Notice this convention, there's no else statement. If you don't return true, the only other option is to go and return false. So you don't need the else statement here. So we can use this method, this tiny helper method, to make this code look a little clearer. I want to say if, let's see, I want to check that all 3 scores are valid. So I'm going to say isValid score 1 and isValid score 2 and isValid score 3. And I want to do something if they're valid, and I want to do something if they're not valid. Most of the work is going to be if they're valid. So if they're valid, do this. else do this. Okay, so this is the true part if they're valid. And in the else part, I'm just going to put a comment for now that says pop up a dialog indicating that data is invalid. And in the true part, when we figure out that they are all in the proper range, what do I want to do? I'm going to make an object of type bowling scores. So there's the reference variable to the object that we're going to create. Bowling scores gets new bowling scores. I keep transposing those, BOWL. And what do I need? For the constructor of bowling scores, it should just pop that up, shouldn't it? Okay, here's a hint for you. When you need help from IntelliSense in Eclipse, control space will help you. So if something doesn't pop up normally, you can press control space it works in a lot of different situations, but if you want the template of the method that you're calling, this is one of the things that you can do. So I couldn't remember the order of the parameters, but I see that we want game 1, game 2, game 3, and then date. So we've got score 1, score 2, score 3. And what are we going to put here for the date? We're going to have to come back and change this eventually, because the date as of right now is today. So when we put the date on the interface, all we did is throw up the current date, and we didn't allow the user to change it. So there's a bit of an issue. We are going to have to allow the user to change the date, and then we're going to have to retrieve the date from the interface and use it here. So for now, and understand that I'm cutting corners, I'm going to simply put in today's date. And that's kind of easy. If you say new date, you get an object that represents today's date. So that compiles. We have an object that we can use now that represents the valid data that the user entered on the screen. I think it would be a good idea to put the series total on the interface. It would be a good idea to put the series average on the interface as well, but I didn't put a widget up there for that, so that's on my list of things to go back to. We have a widget called series total, which is a text view. So I'm going to say series total dot set text. It takes a character sequence, a car sequence. And a car sequence, I dug around a little bit. This is an interface that they made in Android which allows you to use string or string buffer or a whole bunch of different things that are really classes that store sequences of characters. So it is kind of a convenience once you understand what it is. So what we need to do is to pass in the series total from the bowling scores object. So if you remember, we had a method called calculate series score, and there it is. And we can pass that into the set text method. This is an interesting place right here. This compiles But when it runs, I won't bother to go and show you. If you want to experiment with that, you can. When it runs on the emulator, you get this annoying message that says the application has shut down for an unknown reason. No hints of what had gone wrong. Well, fortunately we don't have 10,000 lines of code. We've got a few dozens of lines of code, and it was fairly easy to find out that I passed an int into a method that wanted a car sequence. So I'm annoyed by this. It should have told me that I was doing something wrong right here. Java is a strictly typed language, and it should have said that's not going to happen. But it didn't. So what I'm going to do is I'm going to cheat. I'm going to turn this into a string object by saying, here's an empty string, concatenate it to that integer number. And that will turn an integer number into a string. That's the cheap way of doing it. And everyone does it that way. You're really supposed to make an object of type integer and call toString on that object. And I'm just not going to do it, because people know that you can use the string concatenate operator. This is a string object. It doesn't have anything in it, but it is a string object. The concatenate operator you can concatenate virtually anything to it, and it will turn it into a string. What else do we need to know? Well, I think that's it for now. Notice that the part that is missing, we made this very nice object, but we haven't done anything with it. I mean, we used it to calculate the series score, but we haven't found a way yet of putting it into the application. And that's where we're going next. But before we do that, let's make sure that I hope you're compiling and running more often than I am in this video, because when you get one of those, the application has stopped working and has shut down unexpectedly or whatever it is, you want to see that message before too much has happened. Okay, so let's using this ugly interface where we have to actually delete those numbers, 222, yeah, I'm tired of that. Let's just leave it 300, 300, and then if we click save, the series total appears as 822. So we can kind of believe that our code is working here. And I'm misrepresenting myself somewhat, because when I developed this in my rehearsal, I walked through it in the debugger to see what was going on line by line. So that takes quite a bit of time, more than I wanted to do in this video. But I think you really need to be doing that, and don't be misled by the fact that I just typed this in. I had this code essentially working on another machine, and I'm typing it in based on that. So that's true confessions of the video demonstrator. Like those cooking shows where there's always a cake already in the oven and it comes out perfectly regardless of what happened in the cooking demonstration. Okay, so we have made the next step. We have been able to get the information off of the screen, and we can put information back on the screen. We can hear this save button, and we kind of have started to do what we want to do with the data that's entered from this screen. We've made an object of our own choosing, a custom business object, but we haven't done anything with it yet. While we're here, and this is something that I have a hard time resisting, when okay, this is bad. this text box should not be changing its size. A bowling score cannot have more than 3 numbers in it, and I know I said make a list of things that you're going to change later, but this one is kind of easy. In these, now I guess I need the outline window, and I need the properties window. Yeah, it already knows I was going to want that. We can cause these to maintain their shape really very easily. There's something called ems, and an em is the size of the character m. So I don't want this box to get less than 3 ems wide, and I don't want it to get more than 3 ems wide, no matter what. Let's do that for each of these. And if we save that and then run the application again, we've made an improvement in what the user sees. If you're wondering when it's time to look at the emulator, you can look down here on your console, and if your activity is starting, My Bowling Scores enter scores activity, when that activity is starting, then it is time to go out here and look. So if the user tries to enter a big number, well, you can still enter a big number, but this box doesn't get bigger and smaller depending on what's in it. What we really should do, and this is really definitely going on the list of, we'll come back and think about it later, we really should hear the characters from this widget. So we have not made a listener for this guy at all. We only made a listener for the save button. But we really, a good interface would listen to every character that the user is entering and make sure that they haven't entered a character that they shouldn't be. So if you enter 4 digits in here, don't allow them to put the 4th digit. And that can go on the list of things that we can do later when we're in the polishing stage. Right now we're kind of just learning at a higher level, getting our first application of any significance running. I'm going to minimize that and just leave it running. And now back into the enter scores activity. This is where we left off before I had to go and make that change to the interface. We have an object of type bowling scores, but we didn't do anything with it. It goes away. I mean, it was created here and it went away here. So we haven't gotten this set of data into the application somehow. Eventually we're going to write them all into a database. But we need a way for having data in the application, in the Android application, so that all of the activities can see it. So the flow of control here that we know about so far is that when we run the Android application, the activity that's associated with the launching is the one that will appear. We know that we can make another activity and we can switch control over to that activity and display its layout, but we don't know how to share information among all of the activities. And that's kind of by my design that we didn't talk about that, but we're going to have to talk about it now. So every Android application has a class in it called the application. And it's kind of, you can think of it as a higher level thing, a higher level concept than each of the activities. It's the umbrella class that stores information about the life cycle of all of the activities in the application. No, I'm going to change that. The application class stores information about the life cycle of the application. The activity classes, they control their own life cycle using these on this thing that happened kind of methods. So on create and on exit, or there's a whole bunch of them that the activity can respond to. But we need access to this application class that all Android applications have. So we're going to make a new class, and I'm going to just put it in this same package. And we're going to say new class. And the convention is you name the application class the same as the application. And put application at the end. So my bowling scores application. And we want it to have a parent class of application. And it's not, that's not the complete name of the class, so I'm going to do control space, and it will help me. What kind of an application do I want to inherit from? And I want it to be this one, the class called application in the package android.app. So the fully qualified name of the parent class is Android app application. And I think that's all I need to do there. So I have this class which now gives me access to what's going on in the application object. So we're extending the application. That means we get everything from the parent class, and we can add our own stuff in here. Our objective is to keep all of the data in here that needs to be made available to the various activities in the application. So remember, the issue is the activities are kind of independent units of computation that are off doing stuff, but they need to have shared information about the data in the application. So for our example, each of the activities is going to need to know about all of the bowling scores that have been entered. So we don't just have one set of bowling scores. Every week the user is going to enter their scores for that day, and we want to be able to display them all. And in the enter bowling scores activity, we want to be able to add the bowling scores to all of the previous ones that have been entered. Okay, so conceptually, I think that's a reasonable understanding of what's going on here. This class, the object of this class, which is created when the application starts up, there's only one of them, and it's available to all of the activities. So there is a method, let me refer to what it is called. Of course, it's called getApplication. So you can call getApplication from anywhere, and that object that you retrieve will have whatever is in the object. So what we want in our object is the data for the bowling scores. So I'm going to add an instance variable, which is an Arraylist of objects of type bowling scores. I'll call it all bowling scores. So this array list is going to have all of the data in it that has ever been entered, or that is currently being stored. That might be a better way of saying it. And it doesn't know about array lists, so we're going to import Java Arraylist, and now it's okay. We need to override one of the methods in the parent class. Okay, so we have inherited the methods in the parent class, and one of them we have to add some behavior to it. So this will be interesting. I'm going to say source override implement methods. So if you have agreed to implement an interface, or if you are inheriting from a class and you choose to override some of the methods that you inherit, it will help you. So this is the these are kind of event handlers that are in the application class. So what can an application do? It can be created, it can be terminated, and if memory is low, we can decide what to do. So we could override these and add code to the behavior that we inherit. But we're only going to do one. So when the application is created, we're going to add behavior to the method that is in the application class. So if we use this help from Eclipse, it will give us the correct signature. And look at the first thing that happens is it calls the super method. So when I said we're going to override the method that we inherit and add behavior to it, we need the behavior that's already there to happen. I don't know what it is, but I'm not going to replace the method, I'm going to add to it. So the first thing we do is to call the onCreate method of the parent class. The only way to do that is to use the super keyword, and that little wizard that we went through assumes that you want to do that. And you get this little override indicating that this is an overridden method. So when this application is created, what do I want to do? I want to make this object. So I'm going to say new array list. I thought that might help, but it didn't. So we're calling the constructor of the Arraylist class, and this is going to be a list of objects of this type. That's what, if you're not familiar with generic collection classes, that's what this means. We're going to only allow objects of this type to go into that list. And I have a syntax error. What is it? Oh, for goodness sake. There. Okay, so we have an instance variable in this class, and I didn't add any getters and setters. So let's ask Eclipse to do that for us. Let's say source generate getters and setters for that array list guy. And this is really very helpful, especially when the return data type starts to be complicated. So a getter would return an array list of bowling scores, and a setter would take as the parameter an array list of bowling scores. Now I'm wondering, I don't think I want to allow this to be there. So there's only one instance of the application class created, and it's created right at the beginning. And on create, we create one instance of this array list. There can only ever be one. It should never be changed. So this method, although we kind of always put them in, the getters and setters, automatically, I do not want anyone to change this object. That object for throughout the life of the application should be the same object, the one that is created right here. Well, there's a couple of ways of doing this. I could just delete it, but I'm going to make it private so that no one can call it unless they are in here, and that makes me more comfortable. Okay, so I need one more thing. I need a way for the user of this class to add a set of bowling scores to the array list. So let's make a public void add bowling scores, and the user will pass in a bowling scores object. So here's the array list, all bowling scores dot add bowling scores, and that puts it into the object that was passed in, gets added to the array list. I'm going to put something in here which isn't essential, but I would like you to know about it. I'm going to assert that all bowling scores, no, I'm going to assert that bowling scores is not equal to null. So what are the things that you can pass into a method that takes an object of a specific type? Well, you can pass a bowling scores object, which is what is expected, but you can also pass null. So if someone passes me null, I don't want to add a null or try to add a null to the array list. I think array list allows nulls to be added to it, but I don't want to have to check all the time and when I'm getting stuff out of that array list and say, is this a null object? No, I want to not put it in at the beginning. So I'm asserting that bowling scores is not null. That means that the program will blow up here if someone passes me a null. And I'm satisfied with that. If someone gives me a null and it blows up, that's their problem, because they shouldn't have done that. Would you call add bowling scores if you didn't have a bowling scores to pass me? If you do, it's your problem when it blows up. That's my attitude. Okay, so now we have a way of, once we have a bowling scores object, of putting it into the data for the application. Let's go back to the enter scores activity, and this is the place where we have a bowling scores object. And we want to get the application object and use that object to add that bowling scores object to our array list. So the method that's available from anywhere is getApplication, and that will return us an object which is the application that we're working with. And we need to store that in a reference. Well, we need to keep a reference to that. So the data type is my bowling scores application. People get away with calling these app. Did I spell it wrong? Yeah. Gets, and we have a cast problem here. So it returns an object of type application, which is the parent class of my bowling scores application. So I'm going to use the quick fix of downcast it to a my bowling scores application. So what's available to us in the app? Oh, the one on the top is kind of interesting. And we happen to have called it bowling scores, which is the suggested name, and I don't have to type anything else. Okay, so in 2 lines of code in here, what we've done is this information that we extracted from the user interface and made into a business object, bowling scores. In 2 lines of code, we have added it to an array list that's available to everyone. So every time we enter some data, it will go into that array list. Well, there's one thing left. I keep saying that, don't I? There is one thing left, because we have to go back to the manifest and tell the manifest we have changed. Let me just use the XML. This manifest that is generated for us when we create the application there is a characteristic of application. So this tag application, there is a characteristic of application which isn't being used. It's the default. The default is that the application class will be called application, capital A. And we need to tell it that our application has a different name. And this is how you write it. Put dot and then put my bowling scores application. Okay, so we're telling the manifest when this application is created, instead of using the default application object which they provide, we're going to use the one that we have inherited application, and it's called my bowling scores application. This dot here means that it is in the package com Valencia Programmers my bowling scores. So the operating system, Android, needs to know where is the application class that you're using. So here's the application class that we just created, and it is in that package. So that's what that dot means. If we had put it in a different package, we could specify here a full path, but this is not a huge application. We're not going to have dozens of Java files over here. Okay, I believe. Oh, now we have an error in the. Oh, good. It wasn't a serious error. Android. Why am I transposing those letters all the time? Did that fix it? Okay, No red squigglies. We have a red X over here. Okay. That's good that this would happen, because when you go to changing the XML and changing the Java code and changing the XML, it does a pretty good job of matching everything up, but sometimes you need to tell it to start from the beginning and use all of the fresh parts. So I'm going to clean the project. And our red X over here has been fixed. Oh, I wonder. Aborting build. A parsing exception. A parsing exception. Is that new? Is that new? Is that new? Clear the console once in a while so you can tell if the messages are from the current build. So what am I going to do? I'm going to clean it again. Okay, good. That scared me for a second. We had a parsing error that was left over from an old build. So if I run this, very, very fast. I didn't cut any of the video out because it didn't have to reload the whole operating system onto the emulator. So the activity has started. Let's go out to the emulator and let's say I don't know if you noticed there what I was doing. If you press and hold in one of those edit texts, then you can select Word or select all, and that makes the editing a little easier. On an actual Android device, this is called a long press. So if you hold your finger on something, if you just touch your finger on something, that's a touch. And if you hold your finger on something, it's called a long press. And you, well, depending on how you have the handlers for that particular event, it will do different things. So a long press is a gesture of an Android user. And if we save that, it is showing us the series total. And nothing has happened over here, nothing has blown up. So I think that we have probably added the bowling scores to the array list. That's not good enough. I think we probably did. I need more than that. Okay, I wonder if we can use the same emulator for the debugger. I haven't done that before. In the Enter Scores activity, I'm going to set a breakpoint in here, and let's put it where we check to see if the scores are valid. And I'm going to run this time in the debugger. Remember that we have to use the little bug. And I'm not really sure if I can connect with the debugger using the same. Well, it looks like I can. Well, I'm just going to save those three numbers. See if it hits the breakpoint. And it looks like it did. Minimize the emulator. So we're here now. What's in score 1? Okay, so we got the 3 300s out of the edit text boxes, and we're going to check and see if they're valid. They are, because we're in the true part. Now we're going to make an instance of bowling scores. Let's step over. I'm assuming that it works because I already know it does. That's not a good demonstration. If you open the bowling scores object, make sure that it has the stuff in it that you expect. The date object, that's kind of hard to look at, isn't it? That this one is the milliseconds that have gone by since January 1st, 1970, and that's how a date is stored. So you can't really verify that that is May the 18th, but it is. Okay, so this is where we change the total on the interface, and we saw that that works because you can see it from the interface. This is where we retrieve the reference to the application, and then we're going to add the bowling scores to the array list in the app. So I'm going to step into this one. So here's our bowling scores. That looks right. 300, 300, 300. And let's step over the assertion. And this is where we're adding it to the array list all bowling scores. So let's look at all bowling scores. It's an instance variable in this. So we're looking at the application. Here's the all bowling scores array list. And it has a size of 0. That's good because this has not happened yet. If we step over that, oh, I think it's probably going to take us out of this context. No, that's okay. We can still see it. So an object did get added to the array list. So we can have some confidence that that's working. If I hit continue now, or I guess it's resume in Eclipse, go back to the emulator and let's add put a different number and click save. We should hit the breakpoint again, the same breakpoint we were on before. Check if it's valid, make the bowling scores object. We have the new number that was entered by the user. The series total gets put on the emulator. Retrieve the app. I'm going to step into adding this object to the application. And when we do add that object to the array list in the application, now the size of that array list is 2. So we are collecting objects from the interface and we're putting them into an array list that's available throughout the activities in this application. That's where I wanted us to get in this segment. It's a fairly long segment, and but we covered a lot. What is left now? Well, I don't know if it's obvious, but that array list is going to go away as soon as we shut down. So we haven't persisted the data. We've collected it, but only one run of the application will add objects to that array list in the RAM of the Android device, and when this application is shut down, that array list goes away. This is volatile memory, not persistent memory. So the next thing we have to do, and I'm not sure it will be the next segment, I'm going to have to think about it for a while, we need to persist the data either in a file or a database. A file might be easier, but a database is a lot more interesting. I think we'll use a database. Oh, I shut down the emulator in the middle, but that's okay. That's okay. We can ignore that. Okay, let's look at a summary of what we did in this segment. So our objective in this segment was to get the user's data from the front end. So we are starting now to look at the application in terms of its layers. So the front end is the user interface where we put up the text edit objects and so on, and we talk to it. And then in the middle layer, the business layer, this is where we store the data of the application and do the logic of the application, so the business part of the application. And then the back end is the data layer, where we would persist the data either in files or database or send them someplace else or whatever we want to do with the data. And this is a very common three-tier kind of an architecture for all applications. It doesn't matter if you're building a desktop application or a web application or a mobile phone application. So that's where we've been putting most of our effort into the front end, and now we've just started the middle layer, and we're going to talk about getting the data from the middle layer into the database. So we got data from the GUI and we verified it. We validated that they were valid bowling scores. We didn't pop up an error dialog yet. Don't worry, we'll get there. Put the data into the objects. We made a custom business object, and we made the data available to the other activities. So this is kind of important. How do the activities share information among each other? And you do it through, well, one fairly easy way of doing it is through the application class. So we inherited from the android.app.application and made our own, well, we added some behavior to that application class, including an array list of data that's used throughout the application. So I'm trying to encourage you, as you're working on your application, to keep a list of the bugs that you know about and the feature requests. And you don't have to work on them as soon as you think about them, because if you do, then that leads to something else, and that leads to something else, and that leads to something else, and you go down the rat hole. Oh, I hate rats. So the way of stopping the rat hole syndrome is you keep a record of the bugs that you find and the feature requests that you think of or people tell you about, and that kind of says, okay, I don't have to do it right now because I have it documented, and I can come back to those, and I'm going to keep going in the direction that I intended to go. So everybody, keep thinking about your app, the great killer app that you're going to create, and that's what motivates us to keep going with this, even though it's sometimes a little bit cryptic. It's worth it, because you are going to make that app that will either make you rich or solve all the problems of the world. I'll see you in the next segment.